Okay, this is the 7th time I am trying to record this. So if I sound exasperated, it's not you, it's just the 7th time I have tried to record this. But I unplugged something on my laptop, so I'm going to actually try to start this slideshow, and this time it actually did work. So diagnosed a problem there. So this video is going to take us from going from standard form to vertex form, and it is the first of our algebra tiles lessons. So hopefully you have been paying attention to the algebra tiles warm-ups that we've been doing, and I will do my best to demonstrate this in electronic form for those of you that are not in class. So first off, what are these forms? Standard form is this form here. Now, there we go. Okay, so we get some pen there. Is this form here where you have your ax squared plus bx plus c. So a example of something in standard form might be this, like 3x squared minus 5x plus 2. Okay, so that would be an example of a quadratic in standard form. And then vertex form is what we explored last class. And vertex form is like you've got that a, it's actually the same a value in both of them. And then we have x minus h all squared plus k. And that might be something like this. So you would have 3, and then this is, I'm going to do like a totally different one here. So these are not the same. All right, now each form of a quadratic, and there's one more form that we're not covering in this lesson, but we will cover it, is good for different things. So for instance, standard form is good for factoring. So when we go to factor, we're going to start in standard form. We're not going to start in vertex form. We would actually take vertex form and put it in standard form if that's what we needed to do. Standard form is also really good for finding the y-intercept, which happens to be equal to the c value. So you know where the parabola is going to cross the y-axis. Vertex form is good for determining the vertex. So if you know, for instance, that this quadratic goes left 4 and down 1, then you can locate where the vertex is. It'll be left 4 and down 1. You can kind of sketch the parabola really fast. Also for determining the transformations, which kind of goes along with finding the vertex. All right, now, how do we convert from standard form into vertex form? So how do we go from one form to the other? It's through a process called completing the square. And that can mean something to you algebraically, or it can mean something to you geometrically. Ideally, both. It would make sense, but we haven't really covered enough of the algebra yet. Now, there is a way to teach this using algebra steps, but first of all, it's a lot to explain when you're covering completing the square with algebra steps, and it won't make any sense why we do it. So it would be one of those cases where I would just tell you, take this number, divide it by 2, now square it, now add it, now subtract it. And could you like learn how to follow the steps? Yeah, but none of the steps would make any sense, like why we're doing what we're doing. And then, of course, whenever you have steps that don't make any sense, you're going to forget them, okay? So instead, we're going to do this geometrically using the algebra tiles. So we're actually going to make this a hands-on thing where you are going to manipulate the algebra tiles. And instead of thinking about squares like these kind of squares, we're going to think about squares like those kinds of squares. All right, which, of course, if you've been following with the algebra tile stuff, that is like the area of that square is x squared. So they are connected. But it's a little bit easier to get it geometrically. Also, completing the square only works well for some parabolas. It does work with all of them, but it gets really awful. Yeah, it just gets really awful. So here are the steps. You don't need to write this down because I'm going to model it for you. But first off, you would model the quadratic in standard form. So that's another great feature of standard form. It's good to model with the algebra tiles. And then literally, you're going to make the biggest square possible, okay? So that idea of completing the square, like you're gonna make the biggest square that you can with the algebra tiles. The only rule you need to follow is that you must match up like sides. And in order to keep it nice, we're gonna match up the like sides building to the right and building down, not up and to the left, though you can do it that way. I don't recommend it. And then you find the dimensions of the square and add whatever is left over. Okay. Now, these come in a variety of difficulty levels. So the more experienced you are with algebra tiles, the more you can do with this. But for this lesson, where we haven't really done a ton with the algebra tiles, I'm going to keep it. Oh, hi. You're bringing cardboard. Yes, sure. It's right there. Yep. You want to say hi to the kids in my video? Just say hello. I'm recording, so you can say hi. Well, they can't see you because it's a screen. Okay.
I noticed that your kids kept on asking about cardboard. So.
Yes, they're making their games. All right, thank you. All right, appreciate it. Oh, yep, I'll be here, I think. I hope. All right. So, okay, so I'll show you. So this is our first example. We're going to do x squared plus 4x plus 7. And I'm going to show you an example with negative numbers, and then yeah, so we're going to keep it fairly simple. So x squared plus 4x plus 7. And at this point, I'm going to go ahead and click out of this. And I'm going to take you over to this website. So this is mathsbot.com, manipulatives tiles. And you are welcome to use this for modeling yourself if you don't have a set of algebra tiles at home. I'll try to remember to link the website in Teams so that you have access to it. So we are doing x squared plus 4x plus 7. So if you didn't remember like which one we're doing, we are doing this one right here, x squared plus 4x plus 7. So the first thing we're going to do is model that with the tiles. So I have 1x squared, 4 x's, and 7 units. So I'm going to drag over 1x squared, 4 x's, okay, this is like the longest part, and 7 of these ones. And you'll notice on the screen here that we do have some negatives. And that's where the idea of the area kind of falls apart a little bit, but the model is still going to hold up, okay? All right, and so what I've done here is I've modeled the polynomial, the quadratic in standard form. So 1x squared plus 4x's plus 7. And physically, what we're going to do is build the biggest square that we can. Now, in class, when I have you guys do this with the tiles, I'm just going to let you play around with the tiles because you will learn more if I let you play with it, okay? And so anyway, so let's say we start playing around with this, and I put all of my x's here, okay? So I'm just going to mimic a little bit of playing. All right. And then I have to match up the like sides. So the only place I can put these guys is down here. I can't put it here because remember the one rule that I said that you guys needed to follow was that the like sides have to match up. And so we'll put this here. And then what you can see right off is that this is clearly not a square. It's not going to be a square. Like there's nothing squarish about this. So we say, all right, we've got to do something different here. So what if I take like one of these x's and I move it down here? Okay, so I'm going to click the rotate button. And of course, if you're doing this on your desk, you would just like turn the tile. And now this is like a little bit interesting. So now I've got this, and that looks very rectangular-ish. And I would like to be able to make it more square-ish, except I don't have enough things and I can't put this there because that violates the rule. So let's try moving another one of these. So I'm going to rotate this one and move it down here. Now, what I like about that is by splitting the x's evenly, by splitting them evenly, I know that I'm adding the same amount to each side of my x squared. So I know that this dimension is equal to this dimension. And now I'm going to go ahead and fill this in. And I have succeeded in completing a square with 3 of them left over. Now, I want you to take a good look at that, okay? And what the dimensions of the square are. So we've got x, okay, remember that this is an x by x, because I know that because the area is x squared. This is a 1 and this is a 1. So this entire distance is x plus 2. X plus 2. And this distance is also x plus 2. Okay, so the area of the whole thing is x plus 2 times x plus 2, and then I have this extra 3. Okay, I'm gonna like pause the video here if you want to copy that down, if you need to see it, like x plus 2 and x plus 2. All right, so coming back to this. All right, so now that we've got that, I'm going to try to mimic the thing that we did so that we have a visual for it over here, but it's going to be really bad. All right, just so you know. Oh, that's way too bad. Okay, I've got to at least make it look like it sort of lines up. Okay, and then we had the 3 little ones out here. So what we want to remember is that this was x by x, this was 1 by x, 1 by x, 1 by x, 1 by x. So this dimension up here is x plus 2, and this is also x plus 2. So this whole thing would be x plus 2 times x plus 2, that's the area. And then I have these 3 like that are hanging out here, okay? Like that's just 3. And then we can write x plus 2 times x plus 2 as x plus 2 squared. Because that's what it means to square something. It means to multiply it by itself. And ta-da! We've got it in vertex form. So our standard form was y equals x squared plus 4x plus 7. And the vertex form of the same thing is that. Yay! All right, now let's just say hypothetically, you're like, I'm not sure that I agree that that is the same thing. It sure looks different, doesn't it? It does. So let's go. Oh, the next one we're going to do is x squared minus 4x plus 9. I am going to take a detour over to Desmos for a second, but so x squared minus 4x plus 9, if you're like, what is she going to do? So let's come over here to Desmos. All right, and you might recognize that from class. So what I'm going to do here is type in both of the functions. So this was the standard form, x squared plus 4x plus 7. So there it is. All right, there's my parabola. And then the vertex form was y equals x plus 2 all squared plus 3. And what I want you to notice is that they are generating the exact same graph. So I know that this is the exact same parabola because when I plug in and get those points, I'm getting the same points for both of them. If we wanted to generate the tables, okay, so create a table and create a table. Okay, notice that it is the same table. Like they all have the same points on them. So this one has the point like 219. This one has the point 219, 112 and 112. And I could put in any point I wanted. So I could put in point -5, okay? And I get -512. And if I come down here and put in -5, I will also get the 12. It's on both of the parabolas. So if you're like, I'm not sure, Ms. Taylor, that those actually are the same parabola. Well, go ahead and graph it. And this is a great way to be able to check your work to see if you have actually changed the form the right way, because it should be the same parabola, just written in a different form. All right, now I mentioned this before, just like what I'm going to do next. So the next one we're going to do is x squared minus 4x plus 9. I won't bother blowing that up because I'm not going to write on the slide until after we're done. So x squared minus 4x plus 9. Like, what do? We got negative numbers. So I'm going to click tidy and model this one. So this will be x squared. Now this time it's going to be minus 4x. So I'm going to go ahead and grab these negatives. When you're doing them, you are just going to flip over the tiles and you're going to use the red side of the tile. And the red side of the tile is going to let you know that it is negative. And this time we're going to have a plus 9. So I've got a whole bunch of these that I need to dig out here. So what are we up to? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh. Oh, no. Oh, wait a minute. I might be able to do this. Aha, I can. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay. And if you didn't see what I did there, I dragged one of the negatives over. So I'll kind of show it again. I'll bring it over here. I dragged one of the negatives over and then I clicked flip. Okay. And it flipped it over to make it a positive one. So I had more positive ones. I'll put that back. All right, so we are going to do the same thing. We are going to try to make a square. Now, what I want you to remember from last time is that the only way for me to really get a square was to take my x's and split them up evenly. So if I put like all 4 of them and put all 4 of them on one side here, okay, then I'm not going to get a square because there's not enough of these and it would violate the rules. So I need to split them up. And if I split them up and let's see, we want to rotate that. Okay, that's also not going to give me a square because there's nothing I can do about the fact that these dimensions aren't the same. So whenever you're doing this, one of the things you begin to notice fairly quickly is that in order to make a square, you've got to take however many X rectangles you have and split them in half. And if I were to, I did not line that up very well. There we go. That's better. If I were to give you the algebraic, like how you do this algebra wise, you take the b value and you divide it by 2. And it just kind of comes out of nowhere. Like, why is she telling us to divide it by 2? Why should we have to divide it by 2? And this makes it very visual. Like the reason you need to divide it by 2 is because that's the only way to make a square. Now here, I want you to pay attention. Somebody actually said in class today that like a negative times a negative would give you a positive. So it's actually totally okay that I have positive ones here, because if I do a negative times a negative, it would give me a positive. So in this one, we still have some of these left over, right? Beautiful. Okay, we've got those left over. So we have an x, and now this is like a negative x, but we know that this dimension is still x, so that means this must be a negative 1. So this is x, and then minus 1, and then going down this side is x minus 1, and I have 5 left over. Okay, so I am going to try to do the same thing. I'm going to try to do a copy of that over again. But if you want to pause the video and just get a good look at it, take a photograph of it on your phone, like whatever you want to do. All right, do that. Okay, so here I go. I'm going to try to draw this out. So in this one, we had a big rectangle, which was the x squared, and then we had a negative x and a negative x, and then we had a negative x down here and a negative x here, and then we had these 4. Okay, so when you go to find the dimensions of this is still x, but it's like minus 1, and then this is minus 1. So this is actually x minus 2, and this would be x minus 2 over here. And then we had the, how many did we have left over? 5. We had 5 left over. Okay, so we have like the 5 over here. So this would be, if we were to find the area, it would be base times height. So it would be x minus 2 times x minus 2, and then plus the extra 5. And of course, anytime you multiply something by itself. Oh, you want to say hi? I'm doing a video.
Oh.
Your daughter said hi, so
Oh,
you might as well say hi.
well,
I'm almost done.
Hello.
Yeah, there's no camera
there's
running.
No
it's
camera,
a screen
so I'm just
recording.
saying hello for Miss McDonald in this video that we're making.
Yep, we are.
Okay.
But
Well, I brought you an Amazon bag.
Oh, an Amazon bag.
I came bearing presents.
Oh, wonderful. Well, thank you. I wonder what it is. Oh, I bet you it's tissues.
So now the question can be, what was in the Amazon bag?
Oh, yeah.
Yeah.
Okay. This is going to be a fun video. All right. So here's the changeover. So here is my standard form, x squared minus 4x plus 9. And here is my vertex form, x minus 2 all squared plus 5. Ta-da. Now, last thing I'm going to show you, because we'll go back over and x squared, x minus 2. Okay. All right, so we'll just kind of hop back over to Desmos for a second, and we'll just do that. So the original was x squared minus 4x plus 9, and then our factored form, we have x minus 2 all squared and plus 5. And once again, we see that they are actually the same parabola. And we know that 2 different ways. We know that because we never changed how many algebra tiles we had. We did not change how many algebra tiles we had, okay? So it was the same amount of tiles. All we did was rearrange them, okay? So we didn't mess with it. Now, there are times when we're going to have to add what are called 0 pairs. But we'll talk about that when we get there. And I also know that these are the same because when I graph them, I am able to get the same set of points each time. All right, so that brings us to the end of the lesson, which is the practice. Now, this is going to be turned in on class day because this is actually a really short lesson. It's like a 21-minute video, and that was me doing a lot of stuff here. So I think that this would be classwork. I might make it homework if people can't finish it. If you are doing it from home, you want to go over to the math bots to like access the algebra tiles, and you can do them virtually just like I did. And there you go. Now you'll notice 5 has a little asterisk by it. 5 is going to do something a little different. So I expect questions on 5. And all right, so you guys know where to find me, and I'll see you in class, we hope.